I want to talk about object equality. To understand what I mean by object equality, I want to go back and use a class that we saw much earlier in the course. I'm going to go into the interactive shell, I'm going to import intro CS, and I'm going to make 3 RGB objects. The first and the last are instances of the color red, and the one in the middle is an instance of the color blue. When I talk about object equality, I mean I'm just going to take 2 objects like R1 and B, and I'm going to compare them, asking if they're equal. In this case, it tells me false, and that makes sense, right? Because red and blue, they're completely different colors. But now I'm going to compare R1 and R2. Python tells me true, that they're the same. And that makes sense, right? Because they're both red. But wait a minute, there are 2 constructor calls here. These are completely different folders, right? If I look at the ID of R1, well, that's one number. If I look at the ID of R2, well, that's a completely different number. Just to be sure, let's go over here to the Python tutor. I'm going to go visualize this. So I'm going to import intro CS. I'm going to make my 3 color objects. And now I'm going to ask, is R1 equal to R2? And it says true. They are indeed equal. But here's R1. And here's R2. They're different folders. Oh, okay. If I look at the folders, I notice that all of the values of the attributes are the same. So is that what double equals does? It just takes the 2 folders and checks to make sure that all the attributes are the same? Nope. Let's go do one more example. So I'm going to go import the module frac2, which has our fraction class, and I'm going to make 3 fractions. So the first fraction I'm going to go make is the fraction 1/2. I go look at this. There we go. That's 1/2. Make the fraction 1/3. I'm going to set that equal to q. And I'm also going to create the fraction 2/4. I'm going to set that equal to r. Now if I compare p and q, it tells me false, and that makes sense because 1/2 is not the same thing as 1/3. But if I compare p and r, it says true. If I look at r, I mean, they don't even have the same numerator, right? The numerator of r is 2, and the numerator of p is 1. Oh, but wait, I'm defining fractions. And so if I think of them as fractions, right, 1/2 is indeed the same as 2/4. This is actually doing the right thing here. But how did Python know that? Well, it knew that because this double equals here is an operator, and that means that we have a double underscore method that allows us to define this. So let's go over to Atom Editor, and let's go look at our definition of the class fraction. I'm going to go scroll down. I'm going to go past multiplication and addition, and look at that double underscore EQ, and that's what defines the double equals. Okay, how do I compare fractions? Well, we remember from grade school that we did it with cross multiplication. I'm going to take the 1/2, put it on the left, put the 2/4, I'm going to put it on the right. I multiply the 4 times the 1, that's a 4 on the left. The 2 times the 2, that's a 4 on the right. I compare the 2 sides, they are equal, and that means that the fractions are equal. That's exactly what I'm doing in my code here. Well, actually, if you look at the beginning, what I'm going to do is I'm going to check to make sure that the other is indeed a fraction, because if it isn't, well, they can't be equal. But if it is, then I'm going to cross multiply the 2 fractions, and then I'm going to compare the result of the cross multiplication. Okay, well, that makes sense. So in order to have the double equal symbol, I have to have this special method here. But wait a minute. What if I don't actually have it? So, okay, I'm going to define a new very simple class. We've seen this before. I'm not actually going to do any methods at all. But that's okay because I can still make 2 objects for this. I'm going to make an example in E. I'll make an example of F. And wait, I can still compare them, right? Those are not the same. Well, those are the same, but I never defined the double underscore EQ. Why am I not getting an error here? Well, remember what example is. Example is a subclass of the object class. And oh wait, all of the object class is where all of those double underscore methods come from. It's not the case, so when I go over here in fraction, that I am defining this particular method for the first time. What I'm doing is I am overriding the version that is provided for me by the object class. If I don't override it, I'm going to get the default version. What is the default version? Well, if you look at this, you can sort of guess. It's just going to compare, are they the same folder, right? So if I do another variable, G, set it equal to E. If I look at the ID of G and the ID of E, well, those are now the same folders. And if I ask, is G equal to E, tells me that the answer is true. Oh, okay, so that makes a lot of sense. Now, there are other comparisons that I can do. If I scroll down, you'll notice another one right here. I see this double underscore LT. And what does that stand for? Well, that stands for less than, right? If I want to figure out let's go remind ourselves about our three fractions. So I have P, I have Q, I have R. I want to ask, is P less than Q? Well, no. Is Q less than P? True. How do I do less than? Well, once again, it's just cross multiplication. It's just that I compare the results of the cross multiplication differently. All of the comparison operators are exactly that. They're operators. I can ask, okay, is P greater than Q? Is P greater than or equal to Q? Is Q greater than or equal to P? Okay. But wait a minute. That means that I have to define a lot of double underscore methods, right? Well, okay, I do see one here for double underscore LE, and that stands for less than or equal. But that's it. I'm actually done with my operators. I don't have anything else. Technically, to define greater than, I have to do double underscore GT. And technically, to define greater than or equal, I have to find double underscore GE. But I don't have these. Well, it's because I don't need them. Because let's go think about this, right? If I know what less than is, right? If I can be able to define less than, well, greater than is just the opposite of that. And Python knows that, right? The same thing goes for sort of straight comparison, right? If I know what double equals means, then I also know what not equals means as well. To understand how this happens, let's go over here to the Python tutor. I have my fraction class that's simplified without any encapsulation, and I've got two operators defined. I've got the double underscore EQ, and I have got the double underscore less than. What I'm going to do is I'm going to go visualize this. I'm going to create my class. I'm going to create my two fractions here. I'm going to create my second fraction, which is 1/3. Now what I'm going to do is I'm going to first see if they are equal. So this is going to use the operator double equal sign. And what does that do? That calls the double underscore EQ as a helper. It's going to take the two fractions here. It is going to cross multiply them. It sees that that is different. So it tells me that the answer is false. And now what I'm going to do is I'm going to ask, is P greater than Q? Now I do not have a double underscore GT here. I just have a double underscore LT. But I'm going to call this. Now let's watch what happens. So I'm asking, is P greater than Q? And what it did was it swapped them. It said, okay, well, that means you're asking the same thing, is Q less than P? So I'm going to use Q as the first thing, as P as the second. And now doing that, I'm going to compute the result of less than. That is true. And so that is indeed your answer here. So what I'm pointing out here is, if you want to have any sort of object comparison other than just straight folder equality, you're going to have to define some special methods. So obviously, by the way, we define these special methods inside of the RGB class as well. However, you only need to define two of them. You only need to define double underscore equal right here and double underscore LT. And once you define those two, Python can figure out the